video. And that's going to be on that second worksheet. I have to do one thing. And that is to add the other worksheet, which I haven't added yet. Okay, so that other worksheet we're going to go over in a minute here is adding right now. Meanwhile, any other questions about anything? Okay, let's see if it's loaded. Yes, it looks like it has loaded. Um, I want to find one that's not caught. um, I'm having more challenges today. Uh, um, now my screen sharing has stopped working. My laptop is kind of an old laptop, and I guess it's kind of losing horsepower here. Let me close some files here, and maybe that'll help. I think it's working. Okay. Sorry about it being so disjointed there. Okay. Now, these are mostly from Unit 1, these structures here. I wanted to go over some of these because these are Unit 2 stuff with some acetals, ketals, and that kind of stuff, just for more practice. Okay. So, and reactions are always ones that students do not like. Okay. And again, I'm sorry for that lapse there. Okay. Are you in lab today regarding chastity on Monday? If you're in lab today, we can talk about it some more. Otherwise, if you're in lab Wednesday, just come in anyway, and once I get the lab going, we can talk about it. Will that work? Okay. Well, yes, you can email me. Okay. All right. So we've got a ketone. And this is going to reduce the ketone. So ketones, when they reduce, go to a secondary alcohol. So okay, so here we have a MEacetal, because you've got OCO. That's a yes. We have no we have an OH group, and then we have no hydrogens. We've got another carbon hanging off that. So that's a hemi. Actually, it's not a hemi. It's a hemiketal because of number 3 there. Okay, so hemiketal started from a ketone. We added an acid. Then we're going to add another alcohol. And this time it's going to be a 3-carbon alcohol. So we have the original structure. Okay, so that's 1, 2, 3, 4 carbon backbone. And we're going to add, in the place of the OH, another alcohol. So we're going to have the original structure. And right up here, it's going to be the new alcohol, which is 3 carbon. So we're going to go 1, 2, 4. So that is now a ketal. Right? All right. So here we have an aldehyde and 2 alcohols. And that's propanol. And they are going to add first on the carbonyl group here. And that's going to form a hemiacetal. So the first structure is going to be, so this is a aldehyde. And that goes to a hemiacetal. Backbone is going to be 1, 2, 3. Okay, so the first alcohol here, going where the carbonyl is, and then we'll produce the OH group there. And because I didn't write this worksheet up, by the way, it says 2 moles of the alcohol. In other words, we're going to keep on adding it. So we look at the backbone again. And then where the OH is going to be another one of these alcohols. So this is the hemiacetal, and this is the acetal. Oh, excuse me, this is so once you get used to, doing this is at the beginning of Unit 2, we talked about these acetals and ketals and all that stuff. In fact, I was into a big discussion regarding naming of these guys, ketal versus acetal. And there's a big deal about this. Some people say that ketals are just forms of acetals and all this stuff. So some textbooks don't talk about ketals, some textbooks do. So it's up to the instructor as to whether they want to differentiate between the ketals and acetals. I like to differentiate it because as soon as you say ketal, the origin is a ketone. But if you didn't have the distinction, you wouldn't know whether it originated from an aldehyde or ketone based on your naming. So that's why I do both of them. Okay. All right. So we have a aldehyde again. And we have 2 alcohols, these are methyl alcohols. Again, these are in acidic environments. So the first one we're going to form is going to be the hemiacetal. It's the immunity gas. Continuing on with this methanol again. Oh, and then let's see this. This is the original backbone. Backbone. Okay, when you oxidize a ketone, what happens? Nothing. Now, create. If we did this, this was on your test, remember? This very question. And that was Monday's test. And then Wednesday's test, I put an R here. And when it's reduced, it goes to the secondary alcohol. So it can't be reduced, excuse me, it can't be oxidized, but it can be reduced. Okay, so get some more. All right. Okay, so we have, what is this guy here? Okay, let's do the OCO. We have OCO. And then we have no OH groups, so that means it's not a hemi. And we have no hydrogen there, it's a carbon. So what we have is a ketal that originates from a ketone. That means when we hydrolyze this, throw in water, we're going to end up with a ketone in the end. Okay, so let's look at the backbone, which is, so that is a 1, 2, 3, 4, 5 carbon backbone. Okay, and this is the anomeric carbon here. That anomeric carbon is right here. So that's going to be the focal point for the ketone. But we have to go through a hemiketal first. So that's going to have one of the alcohols still stuck there. I'm going to continue with water. And we have our backbone. And the anomeric carbon, once that alcohol comes off, is going to be where the ketone was. So these are methyl alcohols that originally created the, so once we hydrolyze it, we're going to get that alcohol kicked off. And this problem here is almost exactly the same. Only it's, instead of a ketal, it is a acetal. So we have backbone and that carbon. So these are methyl groups also. So if we reproduce the backbone over here, and the hemiacetal first, let's do a little different. And that acetal is going to kick off 2 methyl alcohols. So one is going to still be here, and it's going to generate a hydroxyl group. And one of the alcohols. Continuing on, going to generate the aldehyde. from which it came. Okay, now sometimes we get into situations where one step is not enough, where you have a multi-step synthesis. Okay, so what do we have here? Okay, we're starting with a secondary alcohol, and we're ending with a ketone. So a ketone comes not from an alcohol, it comes from a ketone. So let's convert the alcohol, secondary alcohols, into the ketone first. So we go alcohol, ketone. Now that we have a ketone, we have acid environment, and we're going to add methanol alcohols. We're going to convert that ketone now into a hemi-ketal. And do the same thing again. So the key step is this first one where you have to get a secondary alcohol to oxidize to give you the ketone. And once you get the ketone, you add in the alcohols. And again, it's just a series of basically what's the intermediate step there. Okay, there's certain things you can do to secondary alcohols. One of them oxidation, the other one is reduction. And what is required to make a ketal? What's required is a ketone to start with the same basic backbone, and with some alcohols thrown in. So these are the alcohols right here. Here we have, this was original alcohol, original ketone. So in the test, I'm going to have one multi-step problem. Okay, so here we have a ketone. Here we have an alkene. What are the ways to make an alkene? Well, we can make it from an alcohol. We pull off the HOH from the alcohol out, create an alkene. So how do we go from a ketone then to a secondary alcohol? Well, we can reduce it. That'll give us a secondary alcohol. And then from there, we can pull off water to generate a double bond. So we reduce the ketone to the ketone, secondary alcohol. Under 80 degrees. So that would be process to get that alkene from the ketone. Okay, and you just wrote out the answers here. Okay, so that's a review of some aldehydes and ketones reactions. Unit 2 type aldehyde ketones. Okay. So let's see what the chat's on. Which one? Tiffany.
The last question you did, wasn't that an aldehyde or am I getting confused?
This right here.
Yeah, number 18.
No, it's a ketone.
Oh, okay. Maybe I just got confused.
Because there's no if we were to draw, let's see, if we were to draw it with carbons, there's no way to put an H in there. Remember, aldehydes are always on the end. So you can't have a cyclic aldehyde because there's no end to the cyclic part. The only way to have an aldehyde as a cyclic would be to have, a carbon coming off of here.
Okay, thank you.
That makes sense?
Yeah, it makes sense. Thank you.
Sure. Okay, so that is it for today. The aspirin lab went pretty well. We had the only thing I changed today from Monday is I'm going to give you a mortar in pestle to grind up the commercial aspirin, because the only thing you guys had to grind it up with was a glass stirring rod. It just kind of crude at best. So that's the only thing I'm changing. Everything else actually went pretty smoothly. Okay, any other questions? Okay, over the weekend, or tomorrow and Friday, email me any questions. I'd be glad to help you out. We can have another Zoom session if you want. I'll have late afternoon Sunday available. I'll have Saturday, I'm teaching up at Sierra, same with Friday. Tomorrow, I can have another Zoom session anytime. Unless I decide to go get a COVID shot up at Costco. So let me know. Send me an email as to my availability. Be glad to have one. Okay, so I will see Wednesday, folks, in a little while.